Studio now is Scott Morris, Associate Professor in Aerospace and Mechanical Engineering. One of Scott's major research focuses is turbomachinery. And in fact, he recently designed and constructed a new cutting-edge turbomachinery laboratory here at the University of Notre Dame. Welcome to Notre Dame Day. Pleasure to meet you.
Thank you.
You brought a toy, but you told me to be gentle so I don't cut my fingers with it. So
That's right.
I won't touch it at all. Turbomachinery, it sounds really awesome, but it also sounds super complicated. Explain to us, just break it down for the people watching here at home today.
Sure. So turbomachinery in engineering is any time you have something spinning, a rotor, interacting with a liquid or a gas, either to move air or move the liquid or gas, or to generate power. And so there's turbomachinery everywhere around you, actually. There's fans, you have cooling fans, you've got fans around you, wind turbines, and the application we're most interested in is gas turbine engines. So gas turbine engines are the primary source of power for pretty much every airplane you've ever been in. Helicopters, tanks, ships, everything has turbomachinery and gas turbine engines.
Yeah, and Scott, lay out your toy here for us. Explain what this is that you brought.
So this is a turbine, and this turbine will typically, this came out of a helicopter engine.
Okay.
And it will spin with high pressure, high temperature gas moving through it, which produces power. And that power, in this case, for the helicopter, will be used to power the rotor for the helicopter, and as well as the electrical generation.
Wow, that's amazing. And explain what your lab does to contribute to gas turbine engine technology.
So the lab that we built at Notre Dame is designed to work on components just like we have here. So we don't work on full-scale engines. The engine laboratory, there's engine laboratories and there's component laboratories. So the work we're involved with is really focusing on improving the quality of the components of the gas turbine engine. So that can be the compressor section, the turbine section, or any of the components that fit together to make the engine. So what we do is we'll take out these components and build laboratory facilities that do research or computations to improve the quality of these parts.
And talk about your lab a little bit. I know that that's your project. Tell us how it is and what stage it started at and where it's at now.
Sure. The lab that we built, we started about 12 years ago.
Okay.
And the idea was to build a laboratory that could sort of fit in between the usual small-scale benchtop laboratories that exist already and the full-scale engine testing that the engine companies and the government does. We wanted to fit right in between. So about 12 years ago, we started with this idea of building laboratories that could study these engine components at a scale that's really relevant to the gas turbine engines without building an actual engine itself. And so we started with that philosophy, and we've built the engine technology into all these laboratory components to the point where we've been growing and adding more capabilities and more computational capabilities and more experimental capabilities year by year, and we've been growing ever since.
And as that growth continues, where do you see this lab over the next 5-10 years?
Well, there's an announcement last year that we're moving part of the laboratory to Ignition Park, which is just south of downtown South Bend in the old Studebaker region. And the new laboratory is going to grow and expand our capabilities to have higher power, higher temperatures, and really more relevant conditions to the engine company. So
a lot going on.
A lot going on. That's
All right,
right.
Scott, I thank you so much for your time today. I know you're a busy guy this afternoon.